Class, welcome back to our second video on trigonometric ratios, okay? So the last video was kind of more of an introduction, figuring out what trig ratios are, and just figuring out kind of how to set them up. Now we're actually going to put them to work. We are going to start solving. Well, in a little bit. We're going to start with a little bit of a warm-up, just to kind of remind ourselves what we're doing and what we have to look for in order to set up these trig functions. So again, if I want to identify which function to use, I need to say, well, this is my angle, which means that this side across from the right angle is my hypotenuse. I have the leg that's next to the 52, which means I have the adjacent, and I don't have the opposite. So let's see here. So ka, toa, A and H, A and H, cosine. Alright? So because I'm looking for the adjacent and I have the hypotenuse, I have to use A and H, the ratio with A and H, which is my cosine ratio. Okay? I keep going, 25 degrees in number 2. That means that I do not have the leg that's next to it, so I'll put an A there. I do have the opposite leg, and I do know that 13 is the hypotenuse, so x 13, that's O over H, or O and H, excuse me. OH, sine. Okay. 3 and 4, let's do these real quick. Let's see here, opposite, adjacent, hypotenuse. Hopefully you're getting pretty good at that. That shouldn't be too bad anymore. If we have an angle, we just look across from it, next to it, and for the side that's across from the right angle. And when we look at this, I have A and H. That's another cosine. And lastly, let's see here, 26. Ooh, I don't have the hypotenuse in this case. So we probably already know our answer, but we'll just kind of finish this up. So 26, oh, here's opposite, here's adjacent. Okay, O and A, if we have O and A, we have to use TOA. So tangent, we're using the tangent ratio. Okay? So now we would know how to set these up, or we would be able to recognize which trig ratio to use to set these up. You're going to need a calculator for a lot of this stuff, because the trig ratios are usually pretty nasty numbers. I shouldn't say, no, I will say that. They're pretty nasty most of the time. There are a few nice ones that we can get into at some point at a later time, but for right now, I need you to understand that these are not the nicest numbers. So, we need to make sure that you are in degree mode on your calculator. So if you have this calculator, you'd want to hit mode, and this DEG stands for degree. You do not want to be in radians. So I'm going to hit that, quit back out. If you have a different calculator, it's similar. You go to the mode. Please make sure that instead of saying radians, you're in degrees. Kind of like that. Okay? And so now, on your calculator, regardless of which one, it said to take the sine of 58. So sine of 58 or sine of 58, doesn't matter. You should get the nice, well, not nice, but a number very similar. Okay? So I'm going to use this calculator for the time being for this video. Sine of 58 is 0.8480, blah, 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 blah. What did it say? It said to round to the nearest hundredth. Let's make a note right now. Please read instructions. Sometimes this changes. You got to read the instructions. Sometimes I'll say hundredth, sometimes I'll say tenth, sometimes I'll say 3 decimal places. Please read the instructions. Hundredth means 2 decimal places. 2 decimal places. So if I look at this 0.848, that means I'm looking right here. This is the last spot I want to write, 0.8, and then I need to decide, am I rounding up or down to the 4? Up to 5 or down to 4? And because this is an 8, I'm going up. Beautiful. Cosine, which is right here on our calculator, of 23 is 0 point, okay, so 0.9 and then 2. Oh, the 0 after the 2 means I'm going to round it down to 2. I'm not going to round up. And we keep going. Tangent, it asks, of 39. Hit enter. Okay, so 0.8. Alright, 0, but the next number is a 9, so I'm rounding up to 1. So 0.81. Alright, so I will let you try these last 3 on your own, and we will talk about them in class, or I'll let you see just to make sure that you're doing okay on these. But the big idea here is that you understand, and you're going to need it, these 3 buttons on your calculator: sine, cosine, tangent. Please don't say sin, cos, tan. It really bugs me. Okay, so let's do some solving. We now have figured out kind of how to set up the trig ratio function or trig functions. We now know how to use our calculator when we need to find the sine, the cosine, or the tangent. So now we need to put everything together. Okay, so 64 degrees, which means here's my hypotenuse, opposite, adjacent. I know that if I'm using the 64 degrees, that x is my opposite, 14 is my adjacent. Instead of just writing tangent here, I'm actually going to set this up now. So that means that I know that the tangent of 64 degrees, right? I had 64 degrees as my angle. I'm using opposite and adjacent, so I have to use the tan ratio of that angle is equal to opposite over adjacent, or x over 14. Well, this is nice and easy. I know that if I'm dividing by 14 on one side, to undo that division of 14, all I'm going to do is multiply by 14, right? Because the 14s cancel over here on the right side. And now I would just go to my calculator and I would punch in what I got, which is 14 times the tangent of 64. 28.7. Okay, so 28.7, and then make sure it says to round to the nearest hundredth. 0, oh, got to round down. So 28.70. Very nice. Okay. Things to keep in mind here, just common errors that I want to try to get out of the way now. Please make sure that if you have any actual numbers, like this 14 that you're multiplying by tan 64, I tend to just put it in the front, because if you used tan 64 and if you forget to close your parentheses, right, like you need to take the tangent of that angle. So normally we would have to do tan of 64 and then times 14, which would be okay. But I bet you understand or know what I'm going to say here. Some people forget to close the parentheses. So some people say tan of 64 times 14, and yeah, that's not okay. Okay? So please make sure that when you're doing these, you either put the number out in front, or you at least make sure to close your parentheses around the angle, because you're taking the tangent of a very specific angle value. Okay? Okay, let's do a few more. When we look at something like number 12, ooh, this one's a little trickier. It's asking for MP. Well, MP's over here, so that means that's where I'm going to put my variable. And I think that's a good idea, because otherwise you might kind of forget what you're looking for. So now that I know that I'm looking for this x, which, if this is 20 degrees, oh, then this is my opposite, and across from a right angle is always the hypotenuse, and then again, that'll be my adjacent. Well, I know that I have to use, oh shoot, I forgot to write this earlier. Opposite, hypotenuse, oh, that's sine, okay? So I know that I need to use the sine of 20 degrees, and I know that's going to be equal to the ratio of the opposite leg over the hypotenuse. So my opposite leg is x. My hypotenuse length is 8.7. And very similarly to what I did on the other problem, I need to multiply by 8.7 and multiply by 8.7. I hope you guys understand why I'm doing that, right? Right now I see division by 8.7. So to undo division of 8.7, I need to multiply by 8.7 because that's what cancels out those 8.7s on the right side to leave me with x, which is what I want. And so now that I'm there, I just go to my calculator. It says I'm going to do 8.7 times the sine of 20 degrees. Close it maybe just to be safe. Okay, 2.9 something. So let's be careful here. 2.9 and then 7, but the next value is a 5, so we're going to round that 7 up to an 8. And so we would write 2.98. One thing that you can also use to kind of help test, hopefully you remember from, oh man, when was this? Chapter 4? The order of sides of a triangle go in the same order as the angles. So for example, if this 20 degrees, if this angle right here is 20 degrees, then this angle down here has to be 70 degrees. And so we should know that the sides should go in order. So because this 90-degree angle is across from the 8.7, it makes sense that the side that's across from 20 is much, much less than the 8.7, right? Because 90 is bigger than 20. If you don't get that, you might want to recheck and see what happened. All right, let's do a couple more. On this next one, let's see. Okay, YZ. YZ's right here, so I'm going to put an X, so I know what I'm looking for. I know that that's my hypotenuse because it's across from the right angle. I know that I have this 38 degrees, so I would say XY is opposite. 12.6 is adjacent. I can set this up. Okay, I got this. All right, let's see here. Da-dum-de-dum-de-dum. A and H. A and H means I'm using cosine. So cosine of 38 equals A over H. 12.6 over X. Oh shoot. This isn't as nice as the other one. I do not like this one as much. Okay, this one, guys, I mean, the one strategy that I'm kind of thinking about suggesting here is to cross multiply. And I guess you could really have used that on all of these, right? Let me go back up and show how that would have worked. Tangent of 64, you can rewrite it as tan 64 over 1. And so when we cross multiply, we would get x, right? 1 times x is x, and then 14 times tan 64 is 28.7. So cross multiplying might be the way to go on these. Because on this one, I think we're going to need it. When I put this cosine 38 over 1, and I now cross multiply, well, that's going to give me x times cosine of 38 equals 12.6. And then if I want x alone, I'm going to have to divide by cosine 38, divide cosine 38. Well, that's going to be real nice on the left side. I'm just going to get x. But on the right side, you got to be really careful in the calculator that you actually do division by cosine of 38. So when we do that, we get 15, whoop, wrong color, 15.9, and then I'm going to round that 8 to a 9. So 15.99. 15.99. And that seems pretty good. That seems pretty good. Why? Because it's my hypotenuse, and I know that my hypotenuse needs to be longer than a leg. Alright? What if I had messed up? What if I had forgotten to divide and I multiplied instead? 12.6 times cosine 38. Uh-oh, 9.9. That's impossible. My hypotenuse can't be shorter than a leg. Alright, so that's a good check. It's just a good check to make sure that things make sense. Alright? Okay. Last one. What's going on here? Okay, so 62 degrees. That means 38 is my opposite. X is my adjacent. I don't have the hypotenuse, so I have to use opposite adjacent. Hopefully you're figuring these out. Tangent. Tangent of 62 is going to equal opposite over adjacent. 38 over x. Oh, this is another one like that. I think I need to cross multiply. So I'm going to put it over 1. And I'm going to cross multiply, which means I'm going to have x tan 62 equals 38. Easy enough. Divide, divide, cancel, cancel. So I get that x should equal 38 over tan 62, or 38 divided by tan 62, 20.20. 20.20. 20.20. Now again, a good check just to make sure. If this was 62, then this has to be 28, and it makes sense that this side that's across from the 28 degrees is smaller, right? 20 is smaller than the 38 that's across from the bigger angle. Okay? Okay. So things that you need to keep in mind. You need to first figure out whether you're using SO, KA, or TOA. Got to. Got to try it. Or got to figure it out. Next thing, you need to understand how to set up that ratio, right? You need to be able to say, well, the tangent of some angle is equal to the opposite leg over the adjacent leg, and then it just turns into algebra. Okay. All right? I strongly, strongly encourage you cross-multiplying. I think that's a surefire way of setting these up and solving them correctly. All right? So, last thing, I want you guys to do these two on your own. Okay, I want you to come to class with these two done to see how you do. All right? I hope you are figuring out this trig stuff. It's not that bad, all right? Once you kind of figure out the different ratios, it's really not that bad. I will see you next time. Peace.